Hello and welcome to another learning session with Ms. Killinen. Would you please go ahead and take out whatever you will use to take your notes, notebook, or digital setup? And would you please start setting up your notes the way you see this template? You don't have to draw all the lines and boxes, but at least set up that our topic today is tipping points, the date, and if you are watching this video any other time than the original time it was assigned, go ahead and of course put your date that you are watching this. And then the essential question we are answering today: how do feedback loops lead to tipping points that affect climate change? This will allow you to have focus notes. You can see that the idea for focus notes is we write some things during the lecture. I'll also give you some time to write some COSTA questions, which helps you process the information. And then later, you can write a summary to answer this essential question. That gives you options for focused review as you are trying to learn this material. One note about our notes today: when you are looking at our slides, anything that is in white, the writing is white, I would say don't write it. White, don't write. Anything that is any other color than white, please write that into your notebook. If you need more time setting up your notes, go ahead and pause this video. Otherwise, let's get into it. So, feedback loops were something we talked about on our previous lesson. We talked about things like, for example, photosynthesis. Photosynthesis is how plants make food, and when it is too hot, the photosynthesis shuts down. Well, then that means that there's carbon dioxide in the atmosphere because plants are supposed to pull in carbon dioxide. So if there's not photosynthesis happening, then there's more carbon dioxide in the atmosphere. The carbon dioxide traps heat from the sun in our atmosphere, which means then our atmosphere gets warmer, which increases the global temperature, which means that the photosynthesis will slow down, and then it repeats. That's a feedback loop. That was one example. So the problem is that feedback loops repeat. Every time they repeat, they can cause that problem to get bigger, and more problems can eventually lead to something so messed up that they reach what is known as a tipping point. So again, this is where your notes would start, this part that's not in white. Here's the definition of a tipping point: it's when small changes lead to changes so big they cannot be reversed. And then, of course, related to climate change tipping point specifically says the changes have caused irreversible damage to the climate system. So something within our atmosphere, our climate, something within our globe, something is changing to the point where we can't go back and fix it. So tipping points. In 2022, the Earth Commission, which is an organization that studies things kind of like the health of our Earth and things they're noticing, identified 16 critical climate tipping points for our Earth. And you can see that these ones that are a red circle, these are things that if the global warming rises to 2 degrees Celsius or less, we are likely to see these things happening. The diamond shape means if it's somewhere between 2 to 4, total increase in our global temperature. And then the triangles you can see are a little more rare. These are the things if we reach that global warming temperature of higher than 4 degrees more than it is now. We are going to focus today on 6 critical tipping points. So that gives you an idea of what our notes are going to look like. The rest of our notes will be 6 tipping points that were kind of critical. We're watching these things. We're seeing if we're starting to see signs that this is happening, because that will help us understand where we are in the climate change concern. So the first one I want to talk about is ice sheet collapse. You maybe know that near the poles there are huge pieces of ice. They could be parts of glaciers or they could just be big sheets of ice. Right now, because ice is less dense than water, that ice is slightly above sea level. As the sea levels rise, what happens is that water, even though it's polar water, it's very cold, it's still a higher temperature than ice is. And so as the sea levels rise, more of that ice is actually in contact with the water, and then that ice is going to start to melt. It's the same thing that happens when you put an ice cube in your soda. That water in that soda starts to melt the ice cube. That's what's happening with polar ice sheets as well. So you can see a picture here. The ice will fall into the water as it starts to melt. It becomes thinner and pieces break off. It's not as attached to the big piece anymore. When the ice falls into the water, this changes some things about the water, which we'll talk about later. Or maybe you remember we talked about that as one of the feedback loops is that the ocean circulation is changing as ice melts into the water. We're not going to be able to put that ice back. So the concern is that we would reach a tipping point where we can't return to the normal level where ice was melting, it was freezing, and then it was melting. That kind of is a normal process, but too much of the ice is melting and then falling into the water. You can see on this diagram that the ice sheet since 1995, you can see that in 95, 93, it was way out here on this purple boundary. And then you can see that there was some that fell off and melted, but then it also refroze. And then in January 2002, a big chunk fell off. And then from here until March of 2002, from January to March, there was a large collapse event. And now the level of the ice sheet is way over here. So this much ice being lost in those 7 years only. So that's an example of a concern, because then if that ice is no longer around, then there's more energy that is being absorbed into the water instead of reflected back out into space. So ice sheet collapse is a tipping point that is a concern. Another one is Arctic sea ice loss. And this is not the same as polar ice collapse. Arctic Sea is more like the surface level of the ice. Like think about lakes that freeze over here in Minnesota, only this is in the Arctic Sea, so way up north, way high latitude. So when the Arctic sea ice goes away, the concern is that if there's less ice, there's less reflectivity. So albedo, reflecting. So ice reflects about 80%. So that's high albedo. But things that are darker, like even water or dirt, absorbs a lot more. So that's low albedo. And so only about 10% is reflected. So what we know is that more heat from the sun is being absorbed into the oceans. So when that surface is frozen and it's ice, then that ice should be reflecting the energy from the sun, and that helps regulate the temperature. But if it's water, if the Arctic Sea is melting, then instead that heat is going into the ocean. So here's again a visual of that. So ice will reflect a lot more energy from the sun back into space, and water absorbs quite a bit. This means that the ocean temperatures will increase. So then that ice is not going to refreeze because the water is too warm, and then eventually will reach that tipping point. And then the concern is that this just, of course, will continue. So it goes from feedback loop where there is melting and then there's freezing and then there's some melting and then there's some freezing. Now the concern is that because the global temperatures are rising, there's more ice melting, which means there's less reflectivity, which means the ocean temperatures are increasing. So then that ice isn't going to free freeze, which means you're going to get more and more ice loss. That feedback loop eventually turns to tipping point. And then the other concern is that because the Arctic water is warmer, way up in the northern latitudes, you get strange weather patterns, which affects the jet stream. So if you think of like the air currents that are affected by water and all those things that are connected in our climate, in our Earth, the concern is these weird weather patterns because of things that are happening that are new. All right, so that brings us to our first break. So if you're new to these lessons, what I do is I break up our lecture and give you a little time to process. So what I'd like you to do, if you have a buddy near you that you're doing this video with your buddy, you can process out loud, write a level 1 question. The recommendation is that you put that question on the side of your notes or somewhere and put a big bubble around it so it's easy to find and it's clearly not part of the notes you're writing down. The Costa level one means it's something you could look up right in the notes. Here's some keywords. You could do a definition or a describe. List two things that are happening that are tipping points. That would be an example of a level one question because you can get it right from your notes. And then the idea is you have these Costa questions to help you review these notes when you're trying to review for an assessment or just to check your understanding. So right now, would you pause the video, take a couple minutes, think first, and then write your question with your buddy, or you can always write your own question and then just ask each other the questions that you wrote to help process. Go ahead and pause the video. All right, when you're ready, come on back. So we'll talk about two more tipping points for our middle section of notes. The next one is Gulf Stream slowdown. So we mentioned in the first one, ice sheet collapse. There's water that is falling into the ocean or the ice is falling into the ocean and that ice is very cold, but it's melting and making the water around it colder, at least for a little while. So that cold melt water from Greenland, that ice sheet collapse, is getting into the ocean. Well, when something's cold, it's going to move slower, it has less energy. So that means that the ocean circulation is going to slow down. You maybe remember from climate factors that near the middle of the globe, by the equator, that water is warm because it gets so much direct sunlight. And that warm water circulates up to the northern latitudes or down to the southern latitudes, the extremes, and it helps warm that really, really cold area. And then that cold water circulates down and cools down the warm area. It's a way to regulate the temperature of the globe. So not one area is getting too hot or too cold. But the problem is this cold water by Greenland is slowing down. It's not moving down like it's supposed to. So one effect is that the middle of the middle of the globe, that water is staying hotter than it's supposed to. So the concern is that if we get to that tipping point where this is going so and so slow, then you're not going to be able to recover from that. This means that if this isn't circulating, you don't get that warm water to come back up, which means that Northern Europe is going to be less warm, and that's going to change their climate, and the people that live there will have to adjust. The other thing is that because this area is not moving away as fast, there's water levels building up. So on the eastern side of the United States, water is building up and there's higher sea levels. Now, if you think about it, stuff that happens over here on the eastern side of the United States, sailing is very big there. So there's yacht clubs and marinas, there's beaches and tourist places. So all of those businesses or people that own homes, they're going to notice that the sea levels are higher, and that can affect living. It can affect businesses, and that can be something that's going to affect people even here in the United States, even in the nearer future. So this is a concern that's being watched about Gulf Stream slowdown. The next one I want to talk about is Amazon forest dieback. So if you remember our biomes discussion, you know that a rainforest, if you were standing in a rainforest, it would be warm, but also really humid. Everywhere you looked, there would be different kinds of plants, trees, and shrubs and flowers. There would be water in lots of places dripping from the plants, collecting on the ground, and lots of animals. Rainforests are a very, very diverse biome compared to a savanna. They kind of show a picture here. Savanna, you might see some plants, but they're really scattered, and the plants themselves are really short and stubby, and they're not very full. It's warm, but it's also dry. There's not a lot of water. You can see that there's more like browns and grays, and there's just not a lot of change either. So the concern is that if the global temperature warms to 3 degrees or higher than it is right now, so again, global temperature, The Amazon rainforest will not be able to continue the way we think of it or see it. It will change into a savanna. So right now, the amount of stable Amazon rainforest is in green. And the concern is if something doesn't change in the next 50 to 75 years, this would be the amount of stable rainforest. Well, this means that there will be decreased albedo. There's a lot of things. Yes, the green is a dark color, but it's not as dark as the browns or the tans in dirt and these kinds of grasses. So there will be less albedo, meaning that there will be more energy absorbed into the ground, which will also increase our temperature. And then the other concern is that because there's so many plants and trees in the forest, those plants and trees are supposed to be soaking up carbon dioxide. And that carbon dioxide then should go into the plants instead of being in our atmosphere. Well, if all of these plants are gone, all of that carbon dioxide that used to get what used to sink into these plants is now going to be in the atmosphere. So then that means that's another feedback loop that will continue. There will be more carbon dioxide, which means there will be more heat trapped in the atmosphere, which will increase the temperature. And then and the possibility of getting that many trees back is not possible. So then that brings us to that tipping point. So if because of all the different things that are happening with global temperature, if it warms up to 3 degrees or higher, again, that's the whole global average temperature, then the concern is that the Amazon forest would turn into a savanna, and then that would reach a tipping point of not being able to recover that much change in carbon dioxide levels. All right, that brings us to our second break. So now you're going to do a level 2 question. So either with a buddy or on your own, you're going to think about something that would be a little more brain involved. So it's not like you can just look up the answer, but you can look up something in your answer. So for example, you could say, sketch a picture of rainforest compared to savanna, because you don't have that specifically in your notes, but you kind of know the difference from other things in your notes. You could say, explain why the US sea levels are rising. On the eastern coast of the United States, because there's some hints in your notes. So go ahead, pause the video, read your notes so far. That's what makes it focus notes and active learning. So pause the video, read your notes, and then take a little time, write a level 2 question. And again, I recommend you either put it on the side of your notes or somewhere and put a big bubble around it so it's easy to find for when you're reviewing, when you're processing. Pause the video, come back when you're ready. All right, welcome back. So we are going to talk about 2 more tipping points in our lesson today. The next one is called monsoon weakening. Now, you might have heard of a monsoon. Monsoon is like a huge rainstorm, like more than anything we see here in Minnesota. Huge, 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 like flooding levels of monsoon, of rain, and it happens for a long time, a monsoon season. And you maybe have heard it in like over by Asian countries and Southern Asia and India, over in that area. That's where we think of monsoon seasons happening. What's happening is there's changing albedo in South Asia. So remember, albedo is reflecting, and because of global warming, the albedo is decreasing. And so what's happening is more warmth from the sun is soaking into the earth. And then that is causing a weakening of the Indian summer monsoon. And this is Indian as by India, the country India. So because there is less monsoon, then there are severe droughts across South Asia. Because you might see this and be like, well, monsoon, that's a flooding rain. That sounds bad. But in this area, these people count on that flooding rain season. It gives them, some communities, that is all of their rain for the whole year. They store it in huge containers. It soaks into the ground for their plants. And then that's enough rain for their plants and their gardens and their farms for the whole year, the whole growing season. So without enough of a monsoon season, then there's severe droughts, which means that If there's less things growing, then again, there will be less albedo because there's going to be more dirt and that's darker, which means then if there's less albedo, there's less reflecting. So that's more energy soaking into the ground, which means the temperature will increase, which means more droughts, less growing, less albedo, and eventually, as the feedback loop compounds on itself, you would reach that tipping point. The other concern, of course, is not just the lack of water, but there are communities where people grow the food and then communities eat that food. So then there won't be enough food to feed communities. Or there could be people that grow food and they sell it to other places. So other places won't have the food that they're counting on. Plus, the income will not be there for the farmers who need that income to feed their families and buy things and pay for things. So the concern is not just the ground and the plants and the water, but of course, how the community has to change and adjust because of not being able to grow the things they need to grow. Monsoon weakening. And the last one I want to talk about is permafrost thawing. So here's a picture from way up north, northern latitudes in the the globe, the whole earth. So you can see that you've kind of got this like grassy top and then this middle that looks kind of like snow or ice and kind of like dark. This is the permafrost. So it's called permafrost because it's generally permanently frozen. And then there's just layers and layers that build up over time. But because the earth is temperature is increasing, that permafrost is not staying permanently frozen. And because there's layers and layers of dead plants and animals, there's a lot of methane trapped in that frozen seafloor and permafrost and sediments. All of that. Methane is in there. Methane is something that is given off when something decomposes. This is why when things are decomposing, it smells bad. Like if you have a compost pile in your home or in your garden, in your backyard, it smells a little bit bad. As it's breaking down into the nutrients, which is a good thing, methane is given off. This is why garbage disposals and garbage landfills smell, because as things decompose, they give off methane. Well, methane is a greenhouse gas. It doesn't stay in the atmosphere as long as carbon dioxide does, but it is still a concern that methane will trap heat. And if there's more methane in the atmosphere, it will trap more heat, greenhouse gas. Global warming, then, the concern is that it will melt the permafrost, and then these methane pieces, these methanes that are deposited in the permafrost, they will be released into the atmosphere. If there's more greenhouse gases, that means significant warming, which means there will be more melting, which means there's more methane. More methane means that's more greenhouse gases, which trap heat. So then there's more warming, more melting, and the feedback loop increases until it gets to the tipping point. Right now, we still have enough changes in our seasons where even if this melts some in warmer seasons, it refreezes in colder seasons, and we kind of go back and forth. The concern is that it will stop freezing enough that we'll have so much methane being released into the atmosphere. So permafrost thawing, a concern related to global warming and different feedback loops. All right, that brings us to the end of our lesson. So before you pack up, before you stop the video completely, think about a level 3 kind of question. Again, you're going to put it on the side of your notes so it's easy to find, or put a big bubble around it so you can use it for studying later. And CASTA level 3 is like pulling ideas from all different parts of your brain, not necessarily even from your notes. So it could be like a prediction. Predict which of the 6 tipping points will have the biggest impact. There's not a right or wrong answer. We don't know. We have ideas and things we've talked about in class or from the notes or things you've heard from different discussions or social media. But the point is that it's a level 3 question because there's not one specific answer. Generalize the 6 different tipping points using your summary skills. That's an example of a level 3 kind of question. So go ahead and you can at this point stop the video and then finish your level 3 question. And then after that, then don't forget to go back and do your summary. All right. Thank you so much for joining today. I hope you learned more about understanding our world, climate change, and tipping points. Goodbye.